Alright, so I'll just start the recording fresh here, because I don't want to record presentations. Alright, so how's PA5 feeling?
So far, so good.
Okay.
The for loops seem to be a little bit easier than I was expecting.
Mm-hmm.
But the cleaning, like obviously we were talking before, that is giving me a bit of a headache for just that leaving space in the middle of the phrase or the middle of the line.
Okay. Yeah, we'll deal with those promptly. In the next.
I'm trying to see how many characters I can squeeze out of it. So far, I've got my program down to 143 characters.
Okay, cool. Awesome.
Yeah, I did notice that test 4 took quite some time yesterday for mine.
Yeah, so it takes my code about a minute. Somebody said they've got it down to 2 seconds by doing some pretty aggressive speed ups.
I got it down to, I think, 1 second, 1.5 seconds.
Wow,
now.
Okay. Well, that's awesome. So if you're having contest with this, there's a time command. I know some people already know this. If you say time and you type in any command, it will time the command for you and tell you how much wall time it took and then how much CPU time it took. So if you're getting down to like, sub-second timing, you can do that for bragging rights. Is there a way to see if test 4 passes all cases? So if you hop onto the server and go into temp PA5, you can run your program. If your program's called main, just say main less than any of these input files, and pipe the output into sort-n, and that should produce output that matches these output files. And so if you do that, you should see
sub-second 0.945 seconds.
Nice.
That's with sort. Without sort, you'd be even faster.
Okay, awesome. So yeah, if you put your output into sort-n, you should get exactly these outputs. And if you want to know if two files are exactly the same, there's a command called difference, D-I-F-F. And if you just say diff and put in the name of two files, it'll tell you if there's any differences or not. But most of the test cases are small enough you can just kind of look at them and see if the output matches or not. Test 4 being the exception because it's really big.
What's the difference between the diff command and the compare command?
I don't know the compare command.
Oh, that's what I've been using. I saw that online, and I thought that was really cool. But I'll see what the difference is. Compare command, if you put in two files, it will tell you the line and byte when it finds the first difference.
Okay. So diff will show you line by line differences between two files, but it does it in an intelligent way. So if you have, for example, if you have one file that looks like this, and you have another file that looks like this, right? If you use a kind of low-grade difference program, it's going to say, oh, these lines are different, and these lines are different, and these lines are different, right? So diff is a little better than that. It'll say, okay, these two lines match up, these two lines match up. Well, this line and this line doesn't match. But if I look ahead, oh, these lines match, and it'll say, hey, these files are the same, except you've got one extra line in this first file. Right, so if you have a subtle difference somewhere, if you change a few characters, if you add a line, delete a few lines, it'll do a reasonable job of saying, what's the same and what's actually different, instead of just going character by character, right? And we can do more with diff. We can use diff and use it for a program called patch that will take one file and turn it into another. But if two files are exactly the same and you run diff, it won't print out anything. And that tells you you've got exactly the same output.
Oh yeah, I just ran it. That's a lot nicer.
Okay, cool.
Yeah, before I had to use sed to print out the line that compare gave me out, but this just gives it to me, so it's a lot easier.
Oh, okay, cool. So someone was asking about was asking in Discord, saying that they were trying to sort the file, and it was changing the contents of it, and I'm not able to reproduce that.
Yeah, I've got my laptop right here. And I just typed the command and it still does that thing. It's still sorting it in a different way.
That's
But
very
it doesn't
interesting.
on my desktop when I do the exact same command.
How are you connected to the server?
I am connected. Okay, so it's a MacBook, and I'm using. I don't know if this makes any difference, but I'm using Fish as the shell for the machine. So
Okay.
And what is it? ZSH. I can't remember what Mac OS uses. So I'm using Fish, and I just SSH into the server, and I type in cat/temp/ba5/test0.out, type into sort-m, and it gives me differently sorted output, like it's using a different algorithm to sort.
That's really bizarre.
A tree before an apple, which suggests that it's using some different method of sorting. And I don't understand why that would be. Maybe it's like counting the letters, whereas before it's not counting the letters. Super weird.
It's very bizarre because I can't think of any reason why the shell that you're running on your Mac would change how the sort command is working, unless there's something really subtle going on, like there's some kind of character translation happening. But I don't think that would affect what's happening on Bash. So yeah, if you can, come by office hours tomorrow. It would be interesting to play with this.
When your office hours in the morning tomorrow, right?
Yeah, 8:30 to 9:30.
I can't make that.
Okay. Yeah, I don't know. That's strange. Let me think about it. All
I
right.
got a quick question too for test 4. So I noticed that dashes seem to be okay. They're in the output.
Mm-hmm.
Do we not worry too much about dashes then?
Unless the programming assignment says to delete them or treat them somehow specially, don't treat them somehow specially.
Okay, so only remove the characters in the PA5 description.
Right, right.
Okay.
Yeah, that's important. Otherwise, a lot of the tests will be different. All right, so we've gone through some commands that you can use with sed to do things like, get rid of multiple spaces, change spaces into underscores. We use tr to convert case, and so on and so forth. What I want to do today is start talking about a more general topic related to some of that, which is the topic of regular expressions, or what you usually see called just regex. And so regular expressions are things that you can search for, things that you can ask to be replaced by other things, but they're more powerful than just a collection of characters listed side by side. So for example, if we want to replace a space with an underscore, we've seen that in sed we could say substitute space / underscore and put a G on there to replace all the spaces with an underscore. But this thing right here, which is a character or a bracket or a quotation mark or something, can be much more powerful than just that. It can be a very complex expression that represents maybe a choice of some characters or a set of characters that has some particular property. And so these are called regular expressions, and it's a really powerful way to do a lot of text processing without having to do a whole lot of coding to go along with it. And so like the grep command, when we say grep, this is searching for regular expressions. Normally we say grep and we just say grep, Nick, file name, and it looks for anywhere in the file that Nick appears. But the thing we search for can be one of these more complex expressions. And we're going to play with this using sed. So we're going to do basically sed quote substitute something with something else. And this will read from standard in, make some changes, write the result to standard out. But we can also do this in VI. If we're in VI and we're on a line we want to edit, we can say colon and then type in this S command, and it'll do that substitution on that line. Or we could say colon $1, $, and type an S command, and it'll do that on every line. So this is a general piece of Unix, right? And it's usable in C and Java and Python and Perl and all sorts of other languages. So it's a big topic. We're going to do a fairly brief pass through it right now. I don't know what is making noise on here, because people's microphones are off.
That's Discord.
Oh, I've got Discord open.
That's the
all right.
notification for that.
Thank you. All right, so let's play around with this. So the way we've been using sed so far is just sed substitute old new. So I could say substitute, you know, A with an uppercase A. And if I say apple, that first A becomes uppercase. If I say happy, that first A becomes uppercase. If I say misspelled aardvark, that first A becomes uppercase. By default, when you do a substitution like this, it only substitutes once per line. So this is saying, look in my input line, standard in, and if you find a lowercase a, replace it with an uppercase A, and then you're done. So it finds an A right here in the first character, replaces that with an uppercase A, and then it's done. And so usually the sed commands we've been using, talking about PA5, we put a G at the end. And the G you can think of as global. And it says, hey, don't just do this once, do this as many times as you can on the input line. So if my input line is aardvark, every occurrence of this pattern gets replaced with an uppercase A. And so we've been using that in PA5 to do things like substitute a space with an underscore. And by putting the G at the end, it does, you know, multiple spaces on the line. But we can do more. So one thing we can do is we can do wildcards. So normally, you know, if we search for an A, it's looking for the letter A. If we search for, you know, a 5, it's searching for the number 5. But if we search for a period, this is a wildcard. And this says match any character. And character is not just a letter, it's anything. It could be a character, a space, a digit, a quotation mark. It'll match anything. It could be a period, it would match that too. So now if I say substitute period with X, and I say hello, well, that period matches any character, and the first character of the line is an H. Well, that's a character, so that gets replaced with an uppercase X. If I do 1, 2, 3, 4, 5, the first character on that line, the number 1, that matches the period, that gets replaced with the X. If I type a bunch of spaces, that first space matches a period, and that gets replaced with an X. So if I wanted to remove the first character of a line, I could replace a period with // and now whatever I type in, the first thing on that line matches the period, that gets replaced with nothing. That removes the first character. If I wanted to remove the first 3 characters on a line, I could substitute ... And now the THI matched the ... those got removed. Now, if I put a G at the end of this, my whole line disappears. Why? Because it looked at the first character on the line, it found a T, and it said, okay, let's replace that with nothing. So that got rid of the T, and the G said, and keep going, see if you can find another match. So it looked at the H, and it said, does that match the period? It says, yes, that does, so it replaced the H with nothing, got rid of that. And the G said, keep going. So I looked at the I and said, how about I? Does that match our pattern? Yes, it does. And it keeps going, and it chewed up the whole line, and it made our whole line disappear. Alright, so period is a wild card, and it matches everything. And if you want to actually delete just a period, right, this is not going to replace a period because the period is a wild card. So if I want to actually match the character period, I can put an escape in front of it. I can put a backslash. And the backslash period says, hey, I'm actually looking for the character period, right? I'm not looking for a wild card. And now if I say hello period bye, it's this sixth character, this period, that matched the pattern. So we can use a backslash to escape a character. And that was funny because I just tried to type a note saying backslash to escape a character, and it didn't show me the backslash. I had to type 2 backslashes. I had to escape the backslash so it would actually show up. So backslashes are magic. Alright, so that's one special character. The next special character is an asterisk. And when we type an asterisk and we have some character before it, it doesn't have to be the letter C, it could be any character. This means 0 or more occurrences of whatever character you put right before the asterisk. Let's see, is it possible to use Bash's built-in regex with standard in, or does it have to read from a variable? I'm not familiar with Bash's built-in regex. I've always used regular expressions through something like sed, and so that might be a way to do it, but I don't know how to use the built-in. Alright, so an asterisk followed by, or any character followed by an asterisk means 0 or more occurrences of that character. So let's say I wanted to get rid of all the letter I's in an input string. So I could say search for an I followed by, you know, search for 0 or more I's, and let's just get rid of that. And this doesn't actually work. And there's a subtlety here. So my input string is something like hi there. And I'm saying substitute 0 or more I's with nothing. So here's what happens when the engine goes through this. It starts at the beginning of the string. And it says, okay, I'm sitting right here, I'm in front of the H. Do I see 0 or more occurrences of the letter I here? It does. It sees 0 occurrences of the letter I. And so it says, okay, so this thing right in the beginning, I'm going to replace that with nothing. And there's already nothing there, and so your string does not change. Right, so this is saying, you know, look out the window if you see 0 or more purple elephants, raise your hands and shout, right? While you look out the window, there's 0 purple elephants, so that's 0 or more. So if we want to make sure that there's at least one letter I, we can do the following. We can say, substitute the letter I followed by 0 or more occurrences of the letter I with nothing. And now if we do that, right, those consecutive I's got chewed up and changed to nothing. And if we simply wanted to take multiple occurrences of the letter I and change it to a single I, we could take an I followed by 0 or more consecutive I's and replace that with just an I. right? And so this is what we were doing with spaces. But if we don't put that G at the end, this only happens once per input line. So it found an I followed by 0 or more I's here. It replaced those with an I. But that was the end of it. We didn't put a G, so that was the end of the pattern matching operation. So if we put a G at the end, and we feed this line in, right? Now, anywhere that there's multiple I's, they get replaced with a single I. So that's what we were doing in PA5 a few days ago when we were looking at replacing spaces with underscores. If you do this with space instead of I, you can replace multiple spaces with an underscore. And so that's part of how we were cleaning up our phrases. All right, we can also use brackets to say, hey, I want to search for one of multiple possible characters. So if I replace bracket aeiou with the letters vowel, what this will do is it will go through the input string, and each point it will see if any of these characters match what's in the input string. So this will replace all occurrences of A, E, I, O, or U with the string vowel. And so if I say this is a test, right, so it replaced the vowels with the word vowel. So you can put things inside brackets like this and match multiple symbols. And if you put a caret in front of this that says match anything other than an A, E, I, O, or U, and in this case I'll replace it with 3 C's, and so if I do the same input string, this is a test, right, everything except the vowels got replaced with a pattern of 3 C's. So those are useful sometimes. We could also just do 5 substitutions, substitute A, then substitute E, and then I, and so on. But sometimes it's convenient to list multiple patterns that you're searching for inside brackets like this. All right, the next thing is anchors. And anchors are powerful. So an anchor is something that's fixed to a particular spot. And in regular expressions, we have 2 anchors. We have a caret, which is an anchor at the beginning of the line. And we have a $, which is an anchor at the end of the line. And so the way you can think about this is if your input string is something like hello, there's a caret in the beginning and a $sign at the end. And the regular expression engine basically sees your input like this, a caret followed by hello followed by a $sign. So if I wanted to get rid of the first character of my line, I could say substitute caret dot / /. The caret will match this, the dot will match the H. And so I can clear out the first character. Like so. Alright, so the first character gets replaced with nothing. So if I wanted to get rid of underscores at the beginning of a line, I could search for caret underscore and replace that with nothing. And now if I have a normal string that doesn't begin with an underscore, it leaves it intact. But if I have something that starts with an underscore, it'll get rid of that underscore. If I have two underscores in the beginning, the way I've written this expression, it's only replacing that first underscore. So if I wanted to get rid of multiple underscores, what could I do? Beginning of the line followed by an underscore with an asterisk, so 0 or more occurrences of an underscore. So regular expressions, or normal expressions look the same. A single underscore gets taken out. Multiple underscores get taken out. I could also have done this as underscore underscore asterisk. It'll do exactly the same.
So how come that works both ways with the double underscore and the single underscore?
Because if I don't find any underscores in the beginning, this whole pattern will fail. Right? I'm looking for, at the beginning of the line, 0 or more underscores. If there's no underscores, right, then technically this matches, and it replaces this stuff before the string, and there is nothing before the string, replaces that with nothing. It doesn't have any effect. It's kind of peculiar that it works both ways. But it's this anchor here that's making the difference. If I didn't have that anchor, this pattern would match everywhere in my string, because my whole string is filled with 0 occurrences of underscores. But the beginning of the string followed by 0 occurrences of the underscore, that would only match in the beginning, and substituting that anchor with nothing has no effect. And it's sort of like this. If I do this, it has no effect on my input, right? The caret is not the first letter of the input. The caret is this sort of imaginary anchor before the first character of the input. And so replacing that with something makes no difference. But if I do replace an anchor with ha-ha, that's going to put a ha-ha into the beginning space before the hello. So it almost works perfectly if you think of your input like this. And so if I replace the anchor with ha-ha, then I see ha-ha, hello. If I replace the anchor with nothing, right, that just goes away and I still see hello. That's how I'm thinking of it today, at least. This is one of these things that, like, the more you mess with it, you'll figure out your own interpretation of how it works. That's the nature of computer science.
So the anchors us at the beginning of a string?
It's the beginning of whatever the input is that you're processing, yeah.
Okay, so if I'm processing my individual phrases because I've got that leading underscore on, any second sentence because I spaced it off of the first phrase, off the column as per standard English formatting, it would work when I say, hey, phrase 1, phrase 2, phrase 3.
Right.
See, I knew in 5 minutes you would solve all of my problems.
There you go.
I just got it working.
Okay, excellent. All right, so anchors are useful. And there's, $sign is the anchor for the end of the string, so same thing. If you wanted to get rid of the last character of a line, I could substitute period, $sign. Period will match anything, but period dollar will only match anything that's at the end of the string. So if I say hello there, that E gets taken off. Now, if I don't anchor it, right, if I just say substitute dot with nothing, it matches the first character. If I say do this globally, it will get rid of the entire string. If I say match anything and replace it with an X, it'll replace every character in my string with an X. If I anchor it at the beginning, it replaces the first letter. If I anchor it at the end, it replaces the last letter. All right, So that's all fun and good, and we can do lots of entertaining of ourselves with these concepts, but we can do a lot more. So this really gets interesting when we start trying to do replacements of parts of strings with other parts of the same string. And so we want to talk about registers. And here's the basic idea. Suppose I have a string like A, B, C, D, E. And I want to swap my first two characters with each other. So I want to turn this into B, A, C, D, E. Okay, so I can put an anchor, and I can put a period to match the A, and I can put a period to match the B. And I want to replace this with whatever matched this, followed by whatever matched this. In other words, this period is going to match the letter A. This period is going to match the letter B. And I want to replace this pair of letters that I matched, A, B, with whatever... I totally did that backwards. This will match the letter A. This will match the letter B. I want to replace this AB with the thing that matched this, the thing that matched the second period, followed by the same thing that matched the first period. So if I put parentheses around a pattern, then whatever matches this gets copied into a temporary place in memory called register 1. And if I put parentheses around a second expression, whatever matches that goes into a memory area called register 2. And I can access the contents of those on this side of the substitute command by saying \2 or \1. So this command is saying start at the beginning of the line with the anchor, match one character, put it in register 1, match a second character, put it in register 2, and replace those with the second character followed by the first character. And so this is a regular expression that'll swap the first two characters on a line. And there's one other complication here, which is we use parentheses enough in regular expressions that if we just say parentheses, it's going to look for a parenthesis. So if we actually mean, don't look for a parentheses, but take this thing and throw it into register 1, we have to put escapes around these parentheses, or in the beginning of the parentheses. So this will end up being, our first of many regular expressions that are relatively easy to write and very painful to read. So let's substitute the beginning of the line followed by any character followed by any other character and replace it with \2 \1. And now if I say A, B, C, D, E, it swapped the first two characters. If I wanted to repeat the first character, three times, I could say let's start at the anchor at the beginning of the line, let's match one character, put it in register 1, and replace it with 3 occurrences of whatever's in register 1. So if I say hello, it repeats that H 3 times. And so now it's a puzzle game to figure out how to use this mechanism to do things. So suppose I want to replace the second character of a string with the letter X. Right? So I want to take A, B, C, D, E and change it into A, X, C, D, E. So I want to match the first character and the second character. And I want to replace it with whatever was in that first character. So I'm going to put this in register 1. And then the letter X. So match one character in the beginning, save it in register 1, match a second character. So in this case that would be A, B, and replace it with what we matched first, A, followed by the letter X. And so we can do all kinds of things like this. One more example, and we'll call it good for the day. So like when I make student accounts at the beginning of the year, I download names from Canvas to get a role, and the names come down as a first name, a space, and a last name. And I'd like to turn this into a first initial, followed immediately by the last name. And so how can I do that? Substitute beginning of the line. Let's pick up a first character. And then any succession of characters followed by a space. And let's just replace that with the character we matched. And so those names change into Unix IDs. Alright, so we'll play more with this tomorrow. And don't worry that these are really confusing to look at. Almost nobody can read these. You can learn to write them, but you know, even when I write these, if I make a mistake, I can't go back and fix the mistake. I just have to rewrite it from scratch. They're really easy for a computer to read, but this is really barely human ingestible for most humans I know, myself in particular. But we can learn to write these, and so we'll get more practice with this tomorrow. If you anchor a character globally, we'll replace every first character. So this is all only happening on one line, but if I do this, it's still only going to replace the first occurrence because the anchor doesn't change, right? The anchor is always a thing before the first character of the line. So even though I'm saying do this everywhere on the line, this pattern only matches one spot in the input line, and that's that H right there. All right, go ahead, please send me an attendance ping on the way out, and hope you have a fantastic day, and I will see you all tomorrow.
But
Have a good one.